Hello, everyone. Thank you for attending the June edition of our monthly webinar series. Today's topic is Avalon and DNSDB to expose the Emotet malware. My name is Emmanuel Yananzadeh. I'm the VP of Marketing for Farsight Security. Today, we're featuring our newest integration partners, King and Union. We'll demonstrate the Avalon Threat Analytics platform together with Farsight's DNSDB. Our presenters are Daniel Schwalbe, Director of Engineering and Deputy CISO for Farsight Security, and Aaron G. Clough, CTO at King and Union. Our agenda today will be DNS and our sensor overview, an introduction to pivoting with passive DNS, the Avalon Threat Analytics platform overview, investigations and collaborations on Avalon, the Emotet background, and a demo showing DNSDB with Avalon to investigate Emotet. Finally, we'll get into a Q&A. So we have lots to cover today. So I will hand it off to you, Daniel. The floor is yours.
Thanks, Emmanuel. So we're going to talk real briefly about understanding DNS, or the domain name system. That's what DNS stands for. Whenever you open up a browser, for example, and you type www.farsightsecurity.com, that pretty much means not a lot to your computer. So the DNS is the mechanism in the background that translates a domain name into an IP address, which is what computers can understand and results in your web browser opening up with the correct website. Most everything we do on the internet, of course, is powered by DNS. You may not realize it, but hundreds of times a day, your various devices, your smartphone, your computer browser will make a DNS request in the background and do this translation in real time, really fast. So whenever that happens, there is a mapping between domain names that humans can remember and type and the IP address that powers the internet in the background. So when you use your mobile device and you use search relies heavily on DNS, and also DNS creates a sort of mapping of the internet. An important thing to note about DNS with whois information, the associated records with a domain, about the owner and technical operator, etc. There's a lot of services out there that allow you to mask your information. It's called whois privacy. You can try to hide the person or organization behind the registration of a domain name. With DNS itself, there really is no privacy. For it to function, you have to have an association between a domain name and an IP address. If you don't have that, it doesn't work. So by being able to query the DNSDB on an IP basis and have an association recorded between a domain name and an IP address, DNS really is the basis of truth. Those associations are necessary to make the DNS work, and therefore, if they can be looked up and queried, it's a very powerful pivot engine. You cannot hide your IP address when you have it associated with a domain name, even if you try to hide your registration record with whois privacy. There is still a lot of information that can be gleaned from that association between the domain and the IP address. Now, this is where passive DNS comes in really handy, because there is no obvious way in how the original domain name system was designed to go from an IP address back to a domain. Now, there is something called a pointer record, without getting too specific here, but there is no requirement that the backwards and forwards lookups have to match. You can look up farsightsecurity.com, you get an IP address, but if you look up that IP address, you don't necessarily get back to the domain. Now, this is where the passive DNS and DNSDB comes into place. We have a global sensor network that's deployed throughout the internet in various different geographic locations, and we collect information what we call above the recursive DNS server. So for example, if you are on your home internet service provider connection, your internet service provider most likely hands you an IP address of a DNS server. When you type in www.farsightsecurity.com, you talk to your ISP's recursive DNS server, who will conduct a lookup and find out what's the current IP address for this particular domain. Now, if somebody else that's also a customer of your ISP has already looked up that name, the recursive server most likely has that IP address in its cache, and the lookup stops there, and it just answers from the cache. Now, if nobody in your immediate network neighborhood has looked up that domain name in a while, then it's no longer in the cache, and the recursive server will go out and do the lookup through the predefined path. It goes to the root server, it then talks to the registry server, and then gets the authoritative answer and comes back. The Farsight Security Sensor Network captures that response, what we call above the recursive server. If it's a cache miss, meaning the answer is not in the recursive server's cache, we capture that transaction. This also provides privacy by design, because we do not capture any information that can be tied back to the end user that was making the query. Simply the interaction between the recursor and the root servers, registry servers, and DNS servers is being captured. We take that information and we store it in a database. We have a historical database that goes back to 2010. And we have tools available that allows customers to query that information. So now, all of a sudden, you can ask the question, hey, this IP address right here, can you tell me what the association with any sort of domain name there is? Which in the original DNS, as it was designed, there is no cross-link like that. But if you query the DNSDB, you can make that correlation between an IP address and a domain, or show me all of the domains historically, what IP addresses have they been associated with. So it's a very powerful method for running queries and making correlations. We have pretty diverse sources in our sensor network. They're in the consumer space, government, higher education, in the enterprise, lots of ISPs and mobile providers, social media providers. There are over 200,000 records per second being updated in the DNSDB. We collect over 5 terabytes of data per day, and there are currently over 100 billion DNS resolutions stored in DNSDB. There's 2 ways to consume this information. Number one is in real time through what we call the Security Information Exchange, or SIE. There are real-time streaming channels that you can connect to if you're a customer and consume this data from us. And then we also have the historical database, DNSDB, which does get updated in near real time in the order of seconds, but it has the advantage that it is a fully queryable database that has historical information going back all the way to 2010. And we have an API and an on-prem solution available that allows you to query the information either through integrating it into your own system or with our various integration partners such as Avalon. So I'm going to talk a little bit about pivoting and what that means. So in having access to this database allows you to run various different queries. So you can say, okay, I'm seeing activity from this particular IP address. Well, what can you tell me about this IP address? You can say, tell me what domains are currently associated with that IP address. Again, the regular DNS does not allow for that, so the database here is the critical link that establishes that. And then you can also say, well, what other host names are associated with that IP address, either over time or currently at this point? And then you can take those host names that you find, and you can say, for example, well, what are the domain name servers, the DNS servers that are currently serving that domain and what other domains might it be hosting. So if you're looking at a criminal enterprise, a malware site, or various phishing sites, bad guys tend to reuse their infrastructure. And so if you can identify what DNS server they're using to resolve their domains, you can do a lot of pivoting and say, oh, show me all of the other domains that possibly are served by the same infrastructure. Chances are there's a pretty high likelihood that those are bad. So with a known bad domain, you can pivot both ways and say, tell me more about this infrastructure. You can also look for similar naming patterns. If you have a botnet infrastructure that has a command and control channel, and they're doing different rolling domain names, you can query for similar naming patterns and say, okay, show me all domains that match this particular pattern and where are they pointing. And so therefore you can do correlation and try to find other command and control hosts. You can look for similar looking answers, especially in SOA records, text records, or SPF records. And you can say, well, this is a particular unique string that may show up in a text record. Well, show me all of the domains that have a text record that looks like that, which again, you can correlate and tie together potential linkages that the regular DNS lookups just don't provide. And then you have indicators that give you more information about a particular host name or IP addresses. Is it a hosting service? Is it an IP address that has 1,000 domains associated with it? Well, that's chances are that's a budget hosting company. So that gives you additional information. Is it a known reverse proxy or a sinkhole? Is it a parking service, or is it, for example, a CDN? There's a lot of very clever things being done with DNS when it comes to content delivery networks, and using the right query in DNSDB will give you a pretty good answer if you have a suspicion and you're tracking down a certain path. So where you can use our information, there's various different integration options. If you have your own threat platform or you subscribe to something, you can consume our information and enrich your information in your threat platform. We have a service for what we call RPC, where you can say, okay, a particular domain has been shown in the DNS and it's been registered or it's been around for less than 24 hours. I may not want to talk to it, so I can block that in real time on the firewall or on the mail server. So we're not accepting email from this particular domain because it's only been seen for the last 24 hours. Chances are, if it's a fairly new thing, that there's a high likelihood that there's some nefarious activity potentially associated with it. You can do orchestration, automation, and bulk queries. You can consume it into your SIEM. You can feed your machine learning algorithm with that. The sky is pretty much the limit for how you want to integrate our information. It's a great tool for security operation centers, threat hunters. You can do indicator of compromise, correlation. The historical lookups can be very useful when you trying to piece together how did a particular compromise happen, especially if it's been around for a while. You can, of course, do time-based analysis and say, see a threat potentially moving from A to B to C and track that in the DNSDB. You can do the FQDN name lookups and fully qualified domain names and correlate those over time. You can enrich your data in your security events manager, and you can also enrich your log information. If you're consuming just IP address in your logs, you could backfill that with DNSDB information, so it becomes more clear what it is that you do. And yeah, at this point, I'd like to hand it over to our next presenter.
Okay, hi folks, I'm Aaron, I'm from King & Union, and I want to talk today about our tool Avalon and about using the Farsight DNS data that Daniel was just talking about in an investigation within the Avalon system. one thing that I'm going to go on and on about in this presentation is collaboration. I feel like we've been talking about this as an industry for a few years now, but we never really dug in and did that well. And one of the main things that we at King and Union have set out to do is to make that better, is to make the collaboration, the working together, the sharing information just easier and simpler and clearer. When we founded King and Union, there were really four main things that we saw as being a real problem. First one was that there's insufficient collaboration, like I was just talking about. Also, there's a lot of missing context around cybersecurity threats that people will see an IP address and say, well, that's malicious, hooray. Manual workflows that we're doing a lot of things by hand, and an inability to manage these overwhelming threat data. You get these just piles of indicators, and you don't really know what to do with them or what they mean. I want to dig into each of these one by one. So first, on collaboration. I was at ShmooCon earlier this year, and Ava Galperin, who was at the EFF, was giving a presentation, and there's a whole pile of people up on stage with her, and she made a really interesting observation, which was that there's a pile of people up on stage with her because intelligence work happens in teams, not solo. And Dave Attell made a similar comment recently that he said there's only one generational divide: collaborative workers who use Google Docs and individuals who use Microsoft Office. Right now, we feel like a lot of the security tools are really in the Microsoft Office model. You're collaborating, but you're collaborating in the same way that you're collaborating with somebody by emailing them. It's just not the same. If you've used Google Docs to write something, it's a very different experience than emailing somebody a Word doc and saying, please send me back your red lines. And we really feel very strongly that we should be moving to the Google Docs model of collaboration on threat intelligence data. Next up, automation. Our threat intelligence people tend to do things very manually, and we have some automation, but we do things by hand all the time. We'll search Google by hand. We'll type who is in the command line all the time. We'll make this giant notepad file. We'll iterate over this thing, do the pivoting that Daniel was talking about earlier. And we end up with these giant text files, these giant Excel spreadsheets that we've typed in by hand over and over again. We work in computers. Computers are about automation. We shouldn't be doing any of this stuff by hand. And frankly, if you're doing threat intelligence, you're probably pretty expensive. You shouldn't be doing this by hand. It's not a good use of your time. And we feel it's really important to be automating this stuff. And lastly, closing the loop. One of the big things we feel like is we need to get threat intelligence reports out of the PDF. A lot of these reports come out, they'll be in a PDF, they'll be in a text doc, and somebody has to go through and take the indicators out of them and say, this email is bad, this URL is bad. And in some cases, you can just toss the PDF at a scraper script, but then someone still has to go through that output and say, this email address is actually the marketing address for the people who put out the PDF. This one is legit. This one is not. This one is Google. We feel like the results of your threat intelligence work should be automatically parsable by your tools. You should be able to just point a URL at them and go. So those are the four things we're trying to do with Avalon. We're trying to make a platform to foster collaboration, automate some of your manual workflows, make it easier to understand what's happening, and make it easy to import this stuff into your SIM. So that's what we're focused on with Avalon. And that's what it looks like. So we'll see a little more in a minute because we're going to go through a demo. But the idea is on the left-hand side, you have a chat window where everybody can talk to each other who's working on the same threat. In the middle, we have a visualization where we're saying, these domain names, I'll point to this IP address. These certificates have been seen on these IP addresses. This email address registered these 5 domain names. And you can see and lay out the relationships between the pieces of information. And on the right side, you have more details about a particular thing, either if you've selected it or about the entire graph itself. And one thing I want to make really clear, which we'll see in a minute as part of the demo, this is a real-time collaboration platform. So you can have multiple people on this. They can make changes. They'll see each other's changes happen in real time, a la Google Docs. You know, the idea of making a change to something and then requiring everybody else who's working with you to reload a page is crazy. We want this to be as real time as we can get. So I've been talking a lot. Let's stop talking in theory and start actually doing something. So let's walk through what analysis would look like in an automated collaborative environment. To do that, I'm going to go after Emotet. Emotet is a banking Trojan. It's been around for a while now. It changes really often. In some cases, it changes daily. There are a number of people tracking Emotet online. They post stuff to various places, to Twitter, to Pastebin, etc. And what I want to do as part of a demonstration for how this works is to build in one of those Pastebin reports. And I want to do it with 3 separate twists. First, obviously, I want to use Avalon. and I want to use Avalon to automate the lookup process. I also want to use DNSDB info to show how valuable it is to do the reverse DNS lookups, do the forward DNS lookups, and find more information. And lastly, and again, coming back to the collaboration theme, I want to work with this and more than one person at once. So let's do a demo. All right, pause. Okay, you guys can see this, right?
Yes.
Great, all right. Hang on, let me get a drink before I go further here. By the way, am I talking too fast?
No, we're keeping up.
Yes.
Feel free to slow down.
All right.
Okay, 3 seconds ago.
Yep, all right. 3, 2, 1. So this is what one of those posts to pastebin looks like. You have a bunch of indicators, in some cases multiple epochs of indicators, and not much else. So let's build on this. First, we're going to come into the Avalon system, and we're going to make a thing that's called a workspace. What is that one for June 8th? And we'll say that we want to cover a time period that covers May and June, just for argument's sake. And we get a blank view of that image you saw earlier. So there's nothing in here yet because we just started. So the first thing I'm going to do before anything else is I'm going to invite somebody else to work with me. In this case, my coworker is named John. And I'm going to say that he can also edit this with me. And actually you see there, the little 2 has shown that John has connected to this workspace. So I'm going to pull the first 2 of these payload sets, just for argument's sake. And this one. And then we're going to do a little bit of housekeeping to just add those to the system. Now, as these go in, I want you to notice something. Little orange bars appeared next to each of these. These are indicators. We have a URL and an IP address. And we'll add an edge or connection between them because we'll take the pastebin information word for it that this IP is related to this URL. A couple things happened automatically in the Avalon system, though. We immediately started looking up both what we call a related workspace and an Avalon lookup. The related workspace is basically saying, has anybody else made a workspace that has this indicator in it already? And that's a way for us to indicate that someone else has already worked on this particular problem. The other one is the Avalon lookup, which is basically a default pivot, like what Daniel was mentioning previously. But we do that pivot 3 rounds out. So, this IP address will resolve to a domain name. That domain name might have an email that registered it, and that email might have registered other domain names. We'll go 3 hops out from this automatically. So I'm going to finish these others. And then what I will say to my friend here is, that. So what you'll see in a minute, as I do the housekeeping on these, is other things will start popping onto the screen, which will be John doing work also. Or in this case, he's just moving stuff around. And as you can see, so I'm doing stuff, John is making changes as well. We're just interacting with the same data in real time. He doesn't have to wait for me. He doesn't have to reload graphs. I can see what he is doing as he does it. I'm going to finish the last little bit of housekeeping to get all these indicators in here. And John's also added a comment to this. Okay. So I'm going to take a short moment and add the second set here. And at each step, what's happening here is the Avalon system is doing that related graph and other backend lookups automatically. And so I don't need to do that pivoting. I don't need to ask the questions that we think it's going to want or that we're going to want answered. It's answering automatically. In this, for example, it's already doing an ASN lookup. It's already doing a geolocation lookup because we know investigators are going to want this information. We just answer the question automatically. And that's part of that automation step I was talking about earlier, is we want to automate as much of people's process as we can. And we're going to end up with a lot of these, and this graph is going to get fairly big at the end, and that's intentional, because we want to show this is the kind of thing where you end up with a lot of data, but that the relationships will start to be very interesting. Okay, so we've got a bunch of data, just sort of one-by-one connections between particular URLs and particular IP addresses. Let's start looking up other stuff. So let's say, oh, let's find out if Farsight actually has some information about this. So let's ask to go check Farsight. What do they have on this particular IP address? Now, one interesting thing to keep in mind here, John may not have a license for Farsight, but I do. And so one of the things that's happening here is he will see the results of a Farsight lookup that I perform if I choose to add it to the graph. So we can actually share data between us, even if one of us doesn't necessarily have a license. Okay, and that got interesting. So let's relay this out to sort of make it a little clearer. And here you can start to see some of the interesting stuff. So we have this one IP address, and that goes to, it's John changing stuff again, and that goes to this domain name, and that goes to yet another IP address. So we're starting to get these chains of information I was talking about earlier. And I'll grab one of the others here out of curiosity. Let's try this one. Okay. Now I believe something really interesting just happened. Yeah, it did. So these two that we had that were disconnected, the 107 IP address and this 202 IP address, so this one here and where to go. This big guy here have now connected. So two of our pieces of information in the investigation have suddenly been connected to each other. That's actually really interesting. They're connected by this certificate. In this case, the certificate is the default certificate for a cPanel installation. That may or may not be an insightful thing to say. That might not be useful to you because it's a default thing. It might appear all over the place. But it's an interesting thread to pull. If you have an IP address that's in two very different places, this one's in Jakarta from Centrin, and this one's in Orlando from DimeKnock, but the same attacker is using the same, and they are both using cPanel, that may be a thread you want to pull as part of your investigation to say, maybe this is how these attackers are doing this. We're not going to have time to dig into all the details of whether or not that's true, but it is still an interesting thread and the kind of thing that really jumps out when you're laying out things visually like this. So in this case, the Farsight lookup came back, and it came back with 1,000 relationships. So I pretty strongly suspect that, in fact, this IP address is really a web hoster, and it kind of looks like that from this information. It's DimeKnock, which is a hosting provider. So we can actually tag this. John's already marked that one red, so we may do the same thing for some of the others. We'll mark anything that looks like a hosting provider IP address that way. So this one, come back with 860 relationships. That's probably also a hoster. Come back with another 800. That's probably also. This one's only got 27, so it might not be. Although it's pointing to DreamHost, so there's a good chance it is. And again, you're seeing the same idea here. We had a URL that points to a particular IP address, and then a bunch of other domain names that would also resolve this IP address. It's the same idea that Daniel was talking about previously with forward and reverse DNS, that we have these relationships between them, and you can lay them out visually. And this one also 1,000 relationships, so it's probably a hosting provider also. So you could build further from this. I don't want to, in the interest of time, I don't want to go a whole lot further. But the idea is this. This one is really the core idea I want you to come to, is that we had two different bits of information. We identified fairly quickly, we used Farsight and some other data to find relationships between pieces of information. We connected two of them through a cPanel default certificate. And we could go further and build a whole lot more, but the idea is this. You can see this. You could see John making changes as I worked on them. He was adding enrichments as I was working. We were doing stuff together. And in just a few short minutes, we got a lot of information and found a couple of interesting threads to pull just from straight up lookups in Farsight and lookups in certificate services in the Avalon system. Yes, the idea is you shouldn't be doing this stuff by hand. So I will stop the demo here. Three, two, one. Well, actually, can you go back one slide? Sorry. 3, 2, 1. And I just want to harp on this really, that the idea here is we're trying to get you away, or get your analysts, or you, if you are an analyst, away from the idea of working by hand, working at a command line, working alone. Your job is to neutralize a threat. Your job is to do the analysis. As much of the scut work you should be doing automatically. And you should be doing that together. You should be doing it with other people because they can help. They may know things you don't. And so your true purpose here is identifying and neutralizing a threat. And you can do that together a lot more effectively than you can do it alone. And we think that's a really important thing to come to. So what did we just see? First, passive DNS, forward reverse, hugely powerful tool. We're seeing that in those clusters of IP addresses and domain names in the graph. We think it's essential for real-time collaboration, just the stuff that John and I were doing back and forth with him adding stuff, with him moving things around, identifying things. At the same time that I was doing it, saves hours of work. There's no emailing back and forth. As you saw with the one graph of relationships, a visual representation of your data is just incredibly important to understand the relationships between your data. Seeing what we had up on the screen earlier in a table, you could have figured out eventually that one certificate connected to those two clusters of information, but it would have taken you hours. And we feel like automation is really important because we feel like engineers should be spending their time doing analysis, not typing who is in a command line 600 times. So do you want me to talk through this, or do you want Daniel to talk through this?
I'm thinking actually, I should just talk through it. What do you think?
Sure, go for it.
Yeah. Okay, give me 2 seconds. Great demonstration, Aaron. I really appreciate it. I think that's a good way to visualize how collaboration could really help out in investigations. And I think the key of what you said was that SOC teams should not be using command lines to really efficiently break down thousands of domains and thousands of possible investigation points. So to get, I wanted to summarize how to get your trial API key so you can put it into the Avalon platform. So just a quick walkthrough. Please visit farsightsecurity.com. On the upper right corner, you'll see a Get Started button. Once you do that, you could go to our free DNSDB trial API and click on that. You'll get a free 30-day trial. It's 100 queries per day. And basically, once you fill out the form, we'll send you out an API key. And at that point, you could drop it into the Avalon platform by first logging in, of course. Then go to your profile and go to the license management page and click on Add a License. And at that point, you could select Farsight as a service and then paste in your API key. Pretty self-explanatory. Obviously, we could help you out at support at Farsight, as well as on the Avalon support side. So we have a bunch of questions that came across while you guys were talking. So I will jump right into those. So the first question is for you, Aaron. How do I integrate Avalon with a SIM?
Fair question. So I didn't have time to get into the details of that in the quick demo. We have a thing we call exports, where you can take one of those workspaces or several of them, you can group them together, and create an export that is basically a URL. And every time the URL gets hit, it will suck down the contents of the graph or the workspace. So you can say, for example, I want that Emotet one that we were just working on, and I want it in CSV format, or I want it in a JSON format, or I want it in StixXML format, or StixJSON, or whatever. And you then would hand that URL to your SIM or your IDS to say, hit this URL every 5 minutes, every 60 minutes, whatever your interval is. And then it would just consume that data automatically.
Great. Thanks, Aaron. Next question is for Daniel. Daniel, how long does it take from the time a DNS record occurs to the time that it shows up in DNSDB?
Definitely sub 1 minute. Average, I think, is somewhere between 15 seconds and 30 seconds. The internet is as real time as it gets, but there are certain conditions that may make that number vary. But sub 1 minute on average is 30 seconds.
Got it. Thanks, Daniel. Another question for you, Aaron. How quickly does one get operational when you start with the Avalon platform?
So it's a software as a service platform. So once we create your organization and your account, you just need to log in. Our creation process takes a few minutes on our side. There's a little walkthrough we'll give you to tell you the basics of it. So you can be done in minutes, frankly.
Great, thanks. I had another one for you. Let's see. So you mentioned the Avalon enrichment data. What is included in that base Avalon set?
Including the base Avalon set, we have certificate services. We have some passive DNS, not quite as voluminous as yours. We have the VirusTotal malware feed, and I'm blanking on the last one. That's the core of it, certainly, though. There's some DNS data, there's some registration data, the VirusTotal malware feed, and certificates.
Okay.
So certificate to IP mappings.
Okay. Another question for Daniel. What are some ways that you could query the DNSDB database?
Yeah, so our flagship product certainly is the API, and it's a RESTful API. So if you have your own ways of programmatically accessing that, you can integrate with whatever existing system you have. We have a handful of reference implementations. We have a C language-based query client with a Python-based query client, and there's also a web-based interface that you can get access to and run queries graphically that way.
Great. Last question is for you, Aaron. When you illustrated the automation, how does one set up, or how easy is it to set up an automation script in Avalon?
So the script right now is preset. So we do the 3 rounds of pivoting against the Avalon data itself. If you want to take another data set, something like Farsight's data, or say like Anomaly or something, it's actually very easy for us to query those services on your behalf. It's the same process as you saw earlier for the adding the Farsight key. You could just add, another key for Anomaly or something like that. In those cases, there is actually an option to click that says include in Avalon enrichment, in which case those 3 rounds of pivoting, we would also query that service using your API key. We don't turn that on by default because, as you saw even in the demo, some of those can come up to 1,000, 2,000 relationships really quickly, and we don't want to burn someone's API key automatically. But you can enable that if you wanted.
Great. So that concludes the questions for today. If anybody has any other questions, feel free to contact us either at info@farsightsecurity.com or info@kingandunion.com. As you can see on the screen, if you want to, by the way, this presentation will be made available on our website under resources. So please look for it there. For your Avalon free trial key, please visit the URL there, www.kingandunion.com/earlyadoptionrequest.html, and same thing on the Farsight side. Our trial API is available there. I hope everyone enjoyed our webinar today. As I said, we'll make it available on demand and in the next couple of days, post edits. And if you have any questions, again, feel free to contact either us or King and Union. And we look forward to seeing you at our next webinar. Thank you, folks. Thanks, Daniel. Thanks, Aaron.